In the Beginning by Dr. Walt Brown. This is page 227. The more features of Grand Canyon. Side canyons. Dozens of vast side canyons intersect the main trunk of Grand and Marble Canyons and cut down to the level of the Colorado River. If it took the mighty Colorado River millions of years to carve the Grand Canyon, why do all these side canyons, with no visible source of water, also cut down to the Colorado River? These side canyons also have side canyons, all connected like branches on a big bushy tree. If these side canyons were formed before the main trunk of Grand and Marble Canyons, most would extend to the opposite side of the main trunk. They don't. If these side canyons formed after Grand Canyon and Marble Canyon formed, many would not cut down to the Colorado River, especially with no visible source of water to carve them. Therefore, these side canyons probably formed at the same time as Grand and Marble Canyons. If the side canyons formed before the main trunk of Grand Canyons, most would extend to the opposite side of the main trunk. But they don't. Okay. Some side canyons, called slot canyons, are much narrower than they are high. See figure 44. Okay, what page are we on? Okay, we'll come back to that. How could such narrow canyons carve so deeply through hard rock? Yeah, let's take a look at that. Ooh, look at them. How could they cut so deeply through such hard rock? Good question. Going back to the side canyons. A few side canyons are barbed. That is, they connect to the main canyon backwards, similar to the barbs in a barbed wire or fishhooks. Tributaries almost always enter rivers at acute angles, but the barbed canyons enter at obtuse angles. Very strange. What happened? A large Nankoweap Canyon, a large side canyon, Nankoweap Canyon, enters the Colorado River from the west near the southern end of Marble Canyon. See figure 122. There it is. There's the canyon. What does it say about? Okay. From the canyon. A civilization once occupied Nankoweap Canyon because it has at least 40 archaeological sites, including granaries, but today is usually dry and barren. Let's see what it says about this Nankoweap Canyon. Okay. Uh-oh, not that. Uh-oh. Pilot error. Nankoweap Canyon. Okay, here we go. There it is, Nankoweap Mesa. Little Colorado River on the top, Grand Canyon, Marble Canyon. So we must be looking south. Nankoweap, region of the unusual erosion. This view is looking southeast from 3,800 feet above the ground. The Little Colorado River enters the southern end of Marble Canyon at the top center. The Little Colorado River enters the southern end of Marble Canyon. Uh-oh. Okay, there's a Little Colorado River. Okay. The yellow line encloses a region of unusual erosion. Notice that on top of the Kaibab Plateau, streams do not flow into the many canyons that cut into the southeast portion of the Kaibab Plateau. So what cut these side canyons, and why are they in such a localized area? Why would the terrain east of Marble Canyon, which is at least 2,000 feet below the top of the Kaibab Plateau, and most of this erosion be so smooth? On top of Nankoweap Mesa are stumps, landslides, and rock falls. How can rocks fall and mud flow onto the top of a mesa? Nankoweap Mesa up here. Marble Canyon, Colorado River. So the water flows down or up here through the Marble Canyon, hits the little Colorado River, and then hits the Grand Canyon. Southern Kaibab tip of the plateau. Okay. Kaibab Plateau, Nankoweap Mesa, Nankoweap Canyon. Okay, notice all those. The little Colorado enters the southern end. The yellow line, okay, top of the hive. Streams do not flow into the many canyons that cut into the southeastern part of the Kaibab Plateau. Interesting. Nankoweap Canyon begins high on the southeastern slope of the Kaibab Plateau. Water flowing from many. That's not what we want. Oh, yeah. No, it's not. We want to go to water flowing from many. Okay, there's Nankoweap. And we want this. From many directions, cut the side canyon. Okay, let's get it again. Let's do it. Okay, let's do this. Nankoweap Canyon begins high on the southeastern slope of the Kaibab Plateau. Water flowing from many directions cut this side canyon and its many tributaries, producing avalanches and mudflows. The mineral composition of the boulders mixed in the debris shows that the avalanche came out of and off of the high Kaibab Plateau. These flows had to be voluminous. These flows had to be voluminous, recent, violent, and fast. The flow was voluminous and recent because it produced Nankoweap Delta, the Grand Canyon's largest tributary delta. If, as some mistakenly believe, the Colorado River was powerful enough to cut through solid rock and carve the entire canyon, why did it not remove this soft delta? The flow was violent and fast because it stacked large, partly eroded boulders up to 200 feet high on both sides of the last 1,000 feet of Nankoweap Creek. Some of the boulders are taller than a man. The Great Unconformity. Fossils are found only in the layers above an almost perfectly horizontal plane called the Great Unconformity. Evolutionists believe this boundary marks the time when all life on Earth began and name it the Cambrian explosion. In the Grand Canyon, it lies about 4,000 feet below the rim and extends above the Colorado River for 66 miles. Above the Great Conformity, the layers are all sedimentary and usually horizontal. Below the Great Unconformity lie either basement crystalline rock or thick sedimentary layers that slope 10 to 20 degrees. Arching. Researchers have long noted that Grand Canyon and Marble Canyon cut down into the top of a long 277-mile arch. Vertical cross-sections, perpendicular to the Colorado River, show how the sedimentary layers and basement rock directly below arched upward. Each cross-section differs slightly depending on its location. For 46 miles along the highest portion of the arch, the canyon descends into the dark basement rock itself, a deep slot up to 1,200 feet deep called the Inner Gorge. Immediately above this Inner Gorge lies the Great Unconformity, above which lie the horizontal sedimentary layers stacked almost a mile high. So let's take a look at the Inner Gorge. The Inner Gorge. Kaibab limestone on top, the basement rock on the bottom, and the basement rock is cracked. Grand Canyon profile. This profile, showing the thickness, shape, and elevation of each of the major sedimentary layers, extends from the dimensions. Basement rock, non-sedimentary rock, is black. Note the differing scales. vertical in feet and horizontal in miles. At these scales, the Colorado River at the top of the left arrow above would be smaller than the period at the end of this sentence. Could that dot of a river carve the vast, wide canyon above it? In general, Grand and Marble Canyons cut down into a broad arch that extends for the length of those canyons. This particular profile cuts across faults. One of the most dramatic aligns with the East Kaibab monocline, which is discussed later. Notice how the layers under the monocline thicken to the right. Inner Gorge, figure 124. How could a river cut a slot up to 1,200 feet deep into such hard crystalline, non-sedimentary rock? To grasp the scale, notice the rafts on the Colorado River. Okay, down here. When a river erodes down through soft sedimentary layers and encounters hard basement rock, further erosion should be primarily horizontal into the softer flanking sedimentary layers. Any erosion into the harder rock would form a shallow bowl-shaped channel, not a deep, nearly vertical crack. The eroded walls of this inner gorge should be smooth, but instead are jagged, because if the river started to cut a deep slot, boulders, not easily moved, even by fast-flowing water, would fill the slot, preventing further scouring and deepening. Instead, as the Grand Canyon formed, so much weight was removed that the brittle basement rock arched up and cracked vertically. The Inner Gorge. And there's the rafts. Wow, 1,200 feet deep. And here, the distant cavern connection. In 1958, the U.S. Army Corps of Engineers, in preparing a fallout shelter, set off red smoke bombs inside Dinosaur Caverns, a massive limestone cavern miles south of the Grand Canyon. 2 weeks later, park rangers saw that red smoke exiting into the Grand Canyon, 63 miles from the cavern. These caverns, now called Grand Canyon caverns, include 4 larger caverns lying up to 1,500 feet below this first cavern. Obviously, the uplift of the Colorado Plateau predated Grand Canyon. The Grand Canyon predated this 63-mile-long underground drainage system, but what was the source of the large volume of groundwater, 5,400 feet above sea level, needed to form this steep, multi-level cavern system? Millions of years of rainfall would not accomplish much deep excavation, because all sedimentary layers south of the Grand Canyon sloped down to the south, so rainwater would not drain toward the caverns from the south, and the Grand Canyon blocked water from the north. Besides, this cavern is one of the driest in the world. Our focus. While the key questions concerning the Grand Canyon is how did it form, other matters can easily distract us. The canyon's beauty, modern history, early habitation and exploration, the mind-numbing list of geological terms and terrain names, and the adventure and stress of navigating its many trails and the Colorado River itself. Hundreds of books have already told these stories, so we will avoid those fascinating diversions and focus on the key question of the Grand Canyon's origin. A reward may await us, as usually happens in science, and as you hopefully see with the flood itself, when a persistent enigma is finally solved, answers to seemingly unrelated problems become obvious. As usually happens in science, and as you hopefully see with the flood itself, when a persistent enigma is finally solved, answers to seemingly unrelated problems become obvious. In the Beginning by Dr. Walt Brown.